Hi there, and welcome back to another Papetti Math YouTube video tutorial where I am going to be teaching you, yes you, Algebra 1. And in this video, we're going to look at exercise number 3, where we're going to be factoring different polynomials. And we have been looking at, in the previous exercise, how to factor a difference of two perfect squares. So let's see where this one takes us. It says, now try to factor the following polynomials. If it is not able to be factored, write not factorable. Also, always look for a GCF as your first step in factoring. Always look and see if there's a GCF. So in part A, is there a GCF? And the answer is yes, there is. Because what number can be divided evenly into both of these terms? And your answer should be 5. Okay, so we're going to divide each of these terms by 5. 5x squared divided by 5 is x squared. And 20 divided by 5 is 4. Well, negative 20 divided by 5 is negative 4. And now we're not done yet, because now we look inside those parentheses and we start again. Is there a GCF? No. So after we determine that there's no GCF, let's see. Is this a difference of two perfect squares? And your answer is yes, it is a difference of two perfect squares. So how we're going to factor that is we're going to put the square root of x squared in the front of each parenthesis. X times x gives you x squared. And the square root of 4 in the back of each parenthesis. 2 times 2 will be 4. We're going to separate those with a plus and a minus. And now we are factored completely. In our next one, we want to take a look and see if we have a GCF. Do we have a GCF? And the answer is yes, we do. So we have 2 times, okay, divide each by 2, and we're left with x squared. 72 divided by 2 is positive 36. Now we look inside these parentheses. There's no GCF. Is it a difference of two perfect squares? And you might have said yes there because you recognize x squared and 36 as perfect squares. But is this a difference of two perfect squares? This is a sum of two perfect squares. And if we have a sum of two perfect squares, we are not able to factor that. So if you ever see a sum of two perfect squares, that's all you can go. You can't go any further than this right here. So this right here is factored completely. And now finally in part C, we have 10x squared minus 90. Once again, do we have a GCF? And both those numbers end in 0, so that should be a simple one to say that that's divisible by 10. And we divide each term by 10 to see what's going to be remaining inside these parentheses. And we'll have x squared minus 9. Now we're going to bring down that 10 over here. And this is a difference, definitely a difference, of two perfect squares. So we're going to have x, and then the square root of 9 is 3 and 3. I'll redo that. Let's erase that. And let's write a 3. And we separate these with a plus and a minus. So our final factorization is 10 times x plus 3 times x minus 3. And here we have factored 3 examples where we have a difference of two perfect squares with a GCF in the first place, and one where we saw what happens when you have a sum of two squares. So if this video is helpful in adding yet another step to this process, please give it a thumbs up, and you're now ready to add one more thing in for exercise number 4. Thank you for watching.